One of the first topics you will encounter in Calculus 1 is limits. This class, we're just going to look at limits from a graphical point of view. And the idea is, when thinking of a limit, you should ask yourself, what is the value of y getting close to? Not necessarily equal to, but what is y getting close to as x is getting close to a given value? It's really pretty easy from a graph. So what does this say? The limit as x gets close to 2, what does f of x, which is y, get close to? So here's our x value. X is getting close to 2. What is y getting close to? It's getting close to 3. In fact, it equals to 3 when x equals to 2. That's not necessarily always the case, as we see in the next example. Same question, different graph. As x gets close to 2, what is y getting close to? I really shouldn't have put an equal sign there. I'm going to put an arrow saying what did it get close to. So here's our x value. What did y get close to? Well, here, when x equals to 2, y equals to 1. But when x was like 1.9 or 2.1, what was the y value getting close to? It was getting to the value of 2. So this dot is kind of a jump. It was a hole in the graph, but y was getting closer to the value of 2 all along until that hole kind of jumped in. Let's look at this one. Again, as x is getting close to 4, 1, 2, 3, 4, what is y getting close to? Well, the good news is there's not a hole or a jump. That's going to be easy. It's going to be that y value. But now number 4, we have a big jump. When x gets close to 3, here's 3, what is y getting close to? Well, when x was like 2.8 and 2.9, y seemed to be getting close to the value of 3. But when x was 3.1, 3.2, y was getting close to the value of 6. That's what we call a mismatch. Y is not approaching the same value on both sides, so we say this limit does not exist. And you can use the abbreviation DNE, does not exist. Again, we have that big mismatch, not approaching the same value. Number 5. Have we done something like this? Yes, we have. So as again, x approaches 2, what is y getting close to? Again, take out that dot and look right around here. What is y getting close to? 4. So that limit is 4. What about number 6? Here's x. Is y approaching the same value? No, we have again that mismatch. So we have a limit of does not exist. So it's all about continuity. If the graph has no holes or leaps, very easy limits. If it has one hole, we have to think about that. If it has a mismatch, we have no limit. All right, let's look at number 7. We have the same graph, 2 questions. So part A, as x approaches 0, what does y approach? I'm going to let you fill that in. And on part B, as x approaches 2, y goes to? What are those answers? Hopefully you got does not exist here, and you got 3 for that one. Okay, we have lots of questions here. Let's take them one step at a time. Part A, as x approaches 4. Here's 4. What is your y value approaching? Well, right around here, what's your y value? 0. Part 2, as x approaches 2, what is y approaching? Boy, that's a big mismatch. Here it's getting closer to probably like 1, here it's getting closer to -4, here it's 3. So what do we have? Does not exist. Part C, we have x approaches 0. What does y approach? Well, there's no holes or jumps, so it's just the y value of 3. Part D, x is approaching -4. That's out here. Again, a big mismatch. It's approaching the value of 2 on the left. It's approaching the value of -2 on the right of -4. Those are mismatch. So again, we have does not exist. And the last one, as x approaches -6, where we have an asymptote, and that's okay to have an asymptote, but it's going up toward positive infinity on the left and down on the right. That's a huge mismatch. That does not exist. So again, finding limits from a graph, very easy, but if you can look at the graph when you do the algebra next semester, hopefully it'll be a little bit easier.